Welcome back everyone. In this video, let us look at another machine learning algorithm called random forest algorithm. The random forest algorithm is a supervised machine learning algorithm that can be used for both classification and regression. In our previous video, we saw another algorithm called k nearest neighbor, which is also a supervised algorithm and can be used for both classification and regression. But here, random forest is a ensemble technique that uses decision tree as its base. So combining ensemble technique with decision trees forms a platform for random forest. In this video, we will be looking at random forest from the scratch. So let us understand how it actually works and how it is used for both classification and regression. So basically, random forest is an ensemble technique. Ensemble technique in simple term means that it is a combination of multiple models. So combining many models together and producing a single output is called ensemble technique. And in specific terms, we call it as bagging or bootstrap aggregation. So random forest follows bootstrap aggregation method. So before that, let us understand when to use this random forest. The random forest is basically used when the data set is very complex or it has multiple dimensions. So dealing with higher dimensional data set, we can easily prefer random forest as it has its own way of dealing with the dataset. We will understand that soon in this video. As said, we can use random forest when dealing with large complex datasets and datasets with higher dimensions. And we can also use random forest when we are dealing with datasets that has higher number of missing data or higher number of outliers. The random forest deals with overfitting as it combines multiple models together. So when combining multiple models, the probability of getting overfitting or the model produces output with higher accuracy can be reduced based on the datasets that we are training. So these are the points that we need to remember when choosing random forest algorithm. And the major disadvantages of random forest algorithm is that it is not suitable for small datasets, and we cannot use random forest algorithm for exploration purposes. We cannot find the hidden patterns or underlying patterns between the data, and it is also sensitive to noisy data since decision trees have higher accuracy. So noisy data may lead to inappropriate result. And the major disadvantage is that doing hyperparameter tuning in random forest is a bit difficult. It requires in-depth understanding of exactly how random forest works and how its parameter actually works during the training phase of the model. So let us understand how this bootstrap aggregation actually works. So let us consider this. So here we are having our dataset D. So this will be our dataset. What we'll be doing is that we will be passing our dataset through various base learners. All these are base learners. This is model 1. This is a separate base learner, and this will be model 2, and this will be model 3, and we'll be having up to model n. So what we will be actually doing is that we will be dividing our data set into multiple subsets and we will be passing to various models called base learners. So consider we have 1000 records of data with 10 columns. Just for an example, I'm saying this 1000 rows and 10 columns. What we'll be doing is that we'll be doing row sampling and feature sampling. That means we'll be dividing our data set into subsets that has different rows with different features. So we'll be selecting randomly different rows with respect to their features. And what we'll be doing is that we will be training those particular records with these base learners. So consider we have 10 base learners. So we will be dividing this data set in a ratio such that different records will be trained in these base learners. So what these base learners will actually do is that they will give a particular output based on the records that they have trained. So consider this base learner gives an output of 1, and this base learner gives an output of 0, and this base learner gives an output of 1, and the last one also gives an output of 1. So what we will be doing now is that we will be aggregating in the sense we are combining all these results together. Now we will be doing a voting for these outputs. So if we see the voting, the majority of the votes is 1. So we will be deciding that 1 is classified as the output. So this process of combining all these models output is called aggregation. Hence this method is called as bootstrap aggregation or also known as bagging. So this is an ensemble technique. So this is an example of classification. What happens in regression is that we will be calculating the mean value or the average value of these results and we will be getting one particular output. And that output will be classified as the final regression value. So this is the base working of random forest. These base learners can be any model, but in random forest, we will be using decision trees. So what we will be doing is that we will be having n number of decision trees. These models are nothing but decision trees. So we'll be having multiple decision trees based on the requirement. So this is how random forest works. In ensemble technique, we can use any model to train our data, but specifically in random forest, we will be using decision tree. So a combination of decision trees that produces an output, and we will be finding the average value for regression and the majority of the value for classification. So this is how the random forest works. So there is a concept called with replacement or without replacement while we divide the subsets of the data. So what this with replacement and without replacement means that we will be converting our data set into multiple subsets. So if we want to repeat a record that has been already in a different subset, and that specific record can be also be present in different subset. So that process is called as with replacement. So it is better to use, my suggestion is that it's better to use with replacement. So multiple records can be present in different subsets. That will increase our accuracy of the model. When I said random forest is used for reducing the overfitting. So what this does is that when decision trees are used, there will be low bias and high variance. So low bias means that our model makes less assumptions with respect to the training data, and high variance means that the accuracy will be very high with respect to the various features that we are going to classify or predict. Usually the low bias and high variance is not preferable when dealing with multiple records. So what we actually do is that we will be comparing multiple decision trees and aggregating them. So this reduces the overfitting. That means each decision tree will be producing a separate output. So when we do with replacement sampling, there might be chances that a record will be trained with different subsets of data. So we will be having n number of decision trees, and each decision tree will be having a perfect output. And combining all these aggregated output and comparing the majority vote, we will be reducing the chances of overfitting. Thus, we will be getting an optimal output from random forest. If you don't know how a decision tree works, let us consider an example and know how decision tree works. So consider this as a decision tree. Now what we want to do is that understand this simple decision tree. Now a person wants to decide whether he have to travel by bus or he should walk. So first we will be looking at the weather. If the weather is sunny or cloudy or rain, based on these categories, the person should decide whether the person has to decide whether he has to walk or take a bus. So consider the first case. If it is sunny, then he has to see whether he has time for to go by bus or by walk. If it is greater than 30 minutes, then we are going to walk, or it is less than 30 minutes, we will be going by bus. Let us consider the case if it is cloudy. And in this case, the person has to decide whether he is hungry or not. If he is hungry, he will walk and go to the nearby restaurant, or he will take a bus directly. So if it is raining, he has to definitely go by a bus. So based on these specific conditions, we are deciding whether the person has to go by walk or by bus. In real time, we will be converting all these categories into numerical features. As machine learning algorithms cannot directly understand categorical features, we will be converting this into numerical values, and based on that, we will be deciding whether what kind of output we want. So this is a very simple decision tree that we are looking at. Like this, we will be having n number of decision trees in our model. We will be having multiple decision trees based on our data set. If our data set has many number of records, then we will be having more number of decision trees with respect to our data set. And like this, based on each decision tree's output, this whole decision tree's output will be either by walk or by bus. So this is based on our person's choice of transport. Like that, in our data set, we will be having multiple decision trees output based on the features and rows that we are training. So converting these features into numerical values, we will be looking at that later in this video. Now let us focus on how this decision tree works and how it actually gives our output. So as said, this is a simple decision tree whether the person has to go by walk or by bus. In similar case, we will be having different scenarios in real time. Based on these scenarios, our decision trees will be giving different outputs, and the majority of the decision trees output will be considered as final output for classification and the average value for regression. So this is how basically a decision tree works in random forest. It is aggregating multiple decision trees together. Hence the name bootstrap aggregating, and all these decision trees output converted into a single output. So this is how decision tree actually works. I hope you got an understanding of how this random forest actually works. So this row sampling and feature sampling plays an important role in the random forest algorithm. So now let us look at the implementation of random forest using sklearn library. Now coming to the implementation part, I have imported all the necessary libraries here. So these are the necessary libraries that are usually used when creating a machine learning algorithm. I have imported pandas, numpy, matplotlib, seaborn, and for model selection, I have imported train test split, grid search CV, and random forest classifier from ensemble library from sklearn. So I'll be using accuracy score, classification report, and confusion matrix, and we'll be looking those things in the later part of the video. So for this particular algorithm, I took this adult income dataset from Kaggle. So this dataset is basically predicting whether the person's income is greater than $50,000 or it is less than $50,000 based on various features that we are going to see now. Those features are age, working class, education, gender, etc. Based on these features, we will be deciding whether the person is receiving salary that is greater than 50,000 or it is less than 50,000. So I'm reading the dataset using pandas. I'll be using read CSV, and I have given this particular name called income.csv in my local machine. So if we see this dataset, we have features like age, work class, final weight, education, martial status, occupation, relationship, etc. All these features are independent features, and this is dependent on all these independent features. So our income, which is dependent feature, is usually the target variable. So we are going to target this income. So we are going, in simple words, we are going to predict the income based on all these features. So whenever we have a data set, it is important to pre-process it. So here I am dropping these two columns at the beginning itself. There is a specific reason why I am dropping these columns. I will explain this when we convert the categorical features into numerical features. I will explain this when we convert categorical features into numerical features. So now I am checking for any null values which is present in our dataset. So this particular syntax will give if there is any null values in our dataset. So as we can see in any of these features, there is not any null value. Using this syntax, we can get feature-wise null values. We can easily obtain which feature has null values. If you want to check whether null values is present or not in your dataset, you can use this particular code. This will either give you true or false. This false implies that we don't have any null values in our dataset. But the thing is, in this data set, instead of null values, they have given question marks. That is, if we don't know the values, we can give null values, but instead that they have given question mark. So it is necessary to look into the data set carefully before you implement it. So here there are values which are mentioned as question mark. So this work class feature has 2800 records of this particular question mark as its value, and occupation it has 2800 records. So instead of null values, we are having question mark. So what I'm going to do is that I'm going to change these question mark values as null values. This particular code will convert that question mark into null values. I'll be using this for loop and loop through every record in those particular column and convert this question mark into null values using this numpy function. And in place is equal to true implies that it will not create any duplicate record. It will be changing in the already existing record. If you give that code again, now we will be getting true. This implies that our dataset has now null values. As we converted that question mark to null values here, obviously we will be having true here. So again, we can see all those question mark is converted into null values, and we will be getting these two as null values. So in this case, I'm going to drop these values. Since our data set has many number of records, we are having around 49,000 records. So to make it simple, I'm dropping all these records from our data set. So this particular code drops all these records. If you want to pre-process or do any other pre-processing technique to deal with null values, you can obviously do that. You can try doing that. So now I'm visualizing this data set after doing those pre-processing. I have dropped two columns and I have dealt with null values. Now I'll be checking for outliers. Before that, let's look into the number of feature values that our columns have. So this work class has around 1, 2, 3, 4, 5, 6, 7 values. So this work class feature has 7 categorical variables. So these are all the variables that are present under work class. So when we convert categorical features into numerical features, it is always necessary to find the number of categorical values in the particular feature. So if the number of categorical variables is high, it will always increase the complexity when converting into numerical values. That particular process is called as encoding. So now I'm checking if there is any feature that has more number of categorical variables. So now I'm checking for outliers. Here no feature has many number of categorical variables. So now let's look at outliers. Now I'll be using z-score for checking outliers. And I have discussed about this z-score in my previous videos. If you haven't checked my previous videos, you can check the previous videos and know more about dealing with outliers. So here I am using z-score from NumPy and checking values. If it is above 3, we will be considering it as outliers. Here there are no outliers. So as said, now we are converting the categorical variables into numerical variables. That particular process is called as encoding, as I said previously. As I said, machine learning algorithms cannot understand categorical variables directly. It needs numerical values to process the data. So this process of converting categorical variables into numerical values is called as encoding. So now let us look at how encoding and the types of encoding. Converting categorical variables into numerical variables, we will be having two types of encoding. One is called as nominal encoding and another one is called as ordinal encoding. Nominal encoding has three types. One is one-hot encoding and one-hot encoding with multiple features, mean encoding. And in the ordinal encoding, we will be having label encoding and target guided encoding. So now we will be focusing only on this one-hot encoding. These are all the different types of encoding that we have. But now in this video, we are going to only focus on one-hot encoding. If you want to know more about this encoding, I'll be posting videos on that in my upcoming videos. So meanwhile, we'll be looking at this one-hot encoding and how it actually works. So consider a categorical feature from our dataset. So here we have various categorical features. So let us consider an example of education. So it has values like 11th HS grade and associate ACDM, etc. So it has different values. So consider this as an example. So now we are going to convert those education features into numerical values. So we are going to do one hot encoding for education. So in education feature, we are having values. Consider we are having values like high school, college, and a doctorate. So we are having three different types of education in our data set. So now we are going to convert these three values into numerical features. So what we are going to do is that we will be assigning values for each of these variables. So I'll be taking this in a table and now I'm going to assign values. So if I'm studying in high school, I'll be giving value for this one and the remaining two will be 0. So if I'm in college, I will be giving 0 for high school and I'll be giving 1 for college and I'll giving 0 for doctorate. So if I'm doing doctorate, these two values will be 0 and this final value will be 1. So if the particular feature has value of 100, then we can easily say it belongs to high school. If it is 010, then it is said to be in college, as college value has 1, right? So in this specific manner, we can assign numerical values to our categorical features. So this is how one hot encoding works. To add more to this, there's a concept called dummy variable trap. So since these values are unique, right? All these values are unique. So if we get a particular row, we can easily say that it belongs to this particular categorical feature. So consider this doctorate feature to be taken away from our dataset. So if the record has 0, 0, then it belongs to doctorate. If this two records belongs to 0, then it belongs to the doctorate categorical feature. This process is called as dummy variable trap. So now we are dropping this particular doctorate column. From this high school and college itself, we can easily say that it belongs to this particular feature. If it is 1, 0, it is high school. It is 0, 1, it is college. If both the features are 0, then it belongs to doctorate. This particular process is called as dummy variable trap. So in one hot encoding, we will be having extra dimensions such that if education feature has three categorical features, then we'll be having extra columns of such features. If education has three categorical variables, then we'll be having two extra features such that high school and college will be present and these values will be true or false. If it is true, here we will be having true value, and if it is false, we will be having 0. Again, this true or false value needs to be converted into numerical values that we will be seeing when we do the code. So if the number of categorical variables in each feature is high, it drastically increases the number of dimensions in our dataset. That is why I dropped this two features in the beginning of the implementation. These two features, native country and education, has more number of categorical features. So when we do one hot encoding, the dimension of our data set, this 15 columns, right? It will increase to more number. The education field has around 40 categorical variables. So if we convert those into numerical values, we'll be having 39 extra columns. So it will be computationally expensive. And the native country also has many number of categorical variables. It has around more than 20 countries. So the number of dimensions in our dataset will increase drastically. It will be computationally expensive and it takes more time to compute the data. So that is why we dropped those two columns at the beginning of the implementation. So now when we look at that particular encoding, we will be using pandas again for it to convert into numerical values. So this data encoder represents the data set after encoding. This pd.getDummies changes these categorical variables into boolean values or either numerical values. This drop first is equal to true implies the dummy variable drop. So now if we look at all these columns, we will be having true or false values. As said, this one-hot encoding will be converting these categorical variables into true or false, and all these dimensions are those categorical variables present in our dataset. All these variables are turned into a particular feature in our dataset. So let us take an example. So let us consider this gender example. So this gender example, we will be having two genders as variable. One is male and another is female. We are seeing only gender male here because it should be either true or false. If we have gender female, it will be exactly opposite to this. So it is better to drop that gender female feature in this dataset. Likewise, every feature's categorical variables has been converted into a separate dimension and it has been represented as true or false. Now it is time to convert this true or false into zeros and ones. I mean numerical values. So now I am converting those boolean values into numerical values in this set of code. So after doing that, if you visualize, all our data will be looking something like this. So this data, this particular zeros and ones and other numerical features represented here, it will be given to a decision tree. So these decision trees will be deciding based on these values of zeros and ones. So multiple decision trees will be deciding the particular output. That means that salary based on these zeros and ones decisions, either whether it is greater than $50,000 or it is less than $50,000. So if you want to know more about the data set, you can use this .info method. So it gives null values or data type of that and how many non-null values are present. So here we are having around 46,000 records of our data. So now I'm visualizing that how many number of records have salary more than 50,000 and less than 50,000. Here zeros represent less than 50,000 and 1 represent more than 50,000. So here the number of people who are receiving salary less than $50,000 or more. It is also important to note that random forest works well with imbalanced data set only when we understand the data set to its depth and understand how it actually works. So here the ratio is pretty close. I mean, it is almost around 30% from the visualization. So if it is one-sided or majorly imbalanced, then we have to then we have to do another approaches before implementing. So now let us do the train test split. Here I'm doing the train test split as usual. Now this train test split, I'm giving the test size as 30% and random state equal to 42. As said, if you want to do row sampling and feature sampling, as said here, we will be doing with or without replacement. In order to do this, we have to give another parameter called as stratify. If we give stratify equal to none, it will do with replacement. In the default case, it will do without replacement. If you want to try this particular thing, you can give this as particular stratify parameter in this train test split. Then you can do with replacement. This with replacement and without replacement, there will be changes in the accuracy of your model once you create it. So now I'm creating the model called as random forest classifier, and I'm doing the fit for the X train and Y train that I have done here. After fitting, I am predicting the X test. So here you can get the values like this. So let us look at the accuracy using accuracy score. This accuracy score is based or it is calculated by total number of correct predictions divided by total number of predictions that our model has made. So here we are getting accuracy as 0.85, which means it is having the accuracy of 85 percentages. So everything is fine. Now, if you look at this, there is a thing called number of decision trees. So how do you know that this is the optimal number of decision trees that is suitable for my model? The random forest itself does not know that this much number of decision trees is suitable for the particular data set. So we have to manually decide the number of decision trees that we are going to do, that we are going to implement in our model. The number of decision trees matters the most. If the number of decision trees is less, it is obviously going to predict wrong. If the number of decision trees is more, then it is obviously going to lead to overfitting. Even though decision trees we are aggregating it, if the number of decision trees is more, then the variance will be very high. If the variance is high, then it leads to overfitting. So now we are going to decide the optimal value for the number of decision trees. For that, we are going to use grid search CV. Here I am giving the n estimators. N estimators is nothing but the parameter that we are going to use in our model. This is one of the hyperparameter. Let's say the number of decision trees to be 50, 100, 150 and 200. So now we are going to decide whether the number of decision trees lies between this or it is not in this range. For this, we have to train the model with all these parameters. So I am giving RF classifier, that means random forest classifier as classifier, and grid search CV to create the model with all these parameters. After fitting that model, now we are going to see the best parameter. So the best parameter here is 150. So if we give the 150 as number of decision trees, that means if we give 150 decision trees to a random forest model, then the accuracy will be better. So now let us create another model with this particular parameter to it. So I am creating another instance of this random forest classifier with random state and 42, and I'm giving this particular best params. This star star implies all these. If we give multiple parameters, then all these parameters will be passed. So this star star best params passes all these best params that we got using grid search CV. You can also try to do hyperparameter tuning for other parameters that we have here. So after giving the best of parameters, then we train our model. We will be getting an accuracy of 0.85 again. So since I have done only for the number of decision trees, the accuracy is still the same. If you do hyperparameter tuning for all the parameters, the accuracy will either increase or decrease based on the parameters. So our model is good to go since it has an accuracy of 85%. So to test our model, I am testing manually our model by passing this set of values. These values I passed it manually. If you want to check with other values, you can always check with your own values. So I am passing this age and final weight and all these parameters by myself. I declared an array and converted it into a 2D array. So now I am making our model to predict for this particular set of values. So it is saying that it is 1. 1 represents that this particular record has a salary that has more than $50,000. This warning is nothing but it is saying that all these features do not have an feature name. So I recommend you to create a data set for testing. In the real-time application, we will be having live data that will be coming to us and we'll be doing the prediction. So in this case, you can either take a particular subset from our existing dataset, or you can create your own testing data to test the model. I recommend you to not to do like this. You always create a particular data set for this and test the model. So this is how we will be testing our model based on the data set. So if you want to visualize the decision tree in a random forest, you can always use matplotlib for that. And if you look at this, this will be our decision tree in the random forest. It will be messy since the number of decision trees is very high, and we are having a huge data set that has around 46,000 records. So it will be something like this. At the end, you will be having the exact results that are needed. So this is how the random forest algorithm works. I hope you had a good understanding of random forest and decision trees and how to implement it. We have seen a lot of things in this video, like working of random forest, decision trees, ensemble techniques, bootstrap aggregation, one-hot encoding, and some other things. And that's all for this video. And I will be posting more videos based on the topics that I have left in this video, such as encoding methods and other things I have left in this video. I'll be creating a separate video for this. So that's all for this video. Hope you like it. That's it. Thank you.